I'll erase these dendrites up here. And the topic is chapter 3, and it's quadratic functions. Here's a general quadratic function. It's this: f of x is ax squared plus bx plus c. You know, the variable is x, and the other variable is y over here. And those numbers, those letters A, B, and C are numbers. They're numbers. They're actually called the coefficients in front of each variable. Like the coefficient of the x squared term is a. The coefficient of the x term is b. They're called the coefficients in front of the variables. I guess there's a constant term here, c. But all these things are parabolas. They're all parabolas. And we've discussed parabolas, but now we're going to discuss them in more detail. Chapter 3 is all about parabolas. And we know that parabolas kind of open up, or maybe they open down. We know that. Actually, there's some sideways parabolas, but we're not going to study those. Do you know why we're not going to study those? Yeah, they're not really a function. That's right. They're not. Y is not a function of x. It fails the vertical line test. So we'll just study these up and down parabolas. And I think you might already be able to tell me what makes it open up or what makes it open down. What's positive? Thank you. That A. That leading one. It's not about the B or the C. It's about that A. If that A is positive or negative, it opens up or opens down, right? Yeah. Hey, and you know, and when it opens up, I guess you say this point could be called a minimum. When it opens down, you could call this point a maximum. But either way, you know what we call that point? The vertex. And I didn't really use that word in chapter 2. I think it came up one day for 5 or 10 minutes, but now that's an important word. For parabolas, that minimum or maximum point is called the vertex. And it is a point. And right off the bat, here's a little formula for you. The formula to find the vertex is this. It's a point. The x value is negative b over 2a. Comma. The y value is this. F of negative b over 2a. So we'll practice finding it. The next 3 weeks, you'll find millions of vertexes. That's what you're supposed to do. Find the vertex of the parabola. It's the key to the whole thing. Finding that vertex, that minimum or maximum point, seems to be the key to the whole thing to me. And this is our little formula. Do you understand where the b's and the a's come from? I hope so. It's these numbers here. Right. There's your A, there's your B. The A is always the number in front of the x squared. The B is the number in front of x. C is the number without a variable over here on the end. So this is how you find the x value at this point. This is how you find the y value. Some students don't. Can you read that? Do you understand what that says?
2A.
Well, that is a 2A. Yeah, I think I heard what you said. And see, what you do is you find this x value, and then in order to find the y value, what this says is plug it in the function. You find this x value, and then to get the y value, you take that x value and plug it into the function. That's what that says. That's what that says, and we'll practice doing it, of course. All right, let's do one. Here, right off the bat, let's do an example. Here's an example. An example here. X squared minus 4x minus 5. And I want a lot of things, you guys. This is what my typical question is, I want this. I would like the vertex, kind of listed as a point. I probably want the x-intercept, and there may be more than one. But I'm going to skip that for now, but I mean, I'm putting it up here, but we're going to want the y-intercept. And I think I might want the range. The range is always a good question. The domain's also a good question, but it's too easy. Do you know what the domain is for any parabola? For any quadratic function, for any parabola, the domain is all real numbers. Thank you. Negative infinity to infinity. The way they look, the way they spread out over the domain is all real numbers. So I guess I could ask you what's the domain, but it's not. It's free points if I do that. It's all real numbers. The range is more interesting though, because the range gets affected by wherever that vertex is, you know. Well, let's do it. I want the vertex, and in order to get the vertex, I start with the x value of the vertex, and here it is. It's this little formula, negative b over 2a. Hey, by the way, what is my a in this problem? 1. What's my b?
4.
Negative 4. Call it negative 4, yep. What's my c?
Negative 5.
Negative 5, yep. Yep, that's my a, b, and c. You should identify those. It's easy. You can make a little note over here. Write down what that is. I can see them. I don't need to write down what it is. But a is a 1. B is negative 4. C is negative 5. And here's the formula. Negative b over 2a. That's negative b. Of course, that's negative a negative. That's going to end up positive. Over 2 times a. And a is a 1. This is not difficult. That is a 4 over 2. That is 2. And some people say, hey, cool, that's the vertex. And again, hang on, that's the x value of the vertex. It's sort of half the vertex. The vertex is a point, and you just, so far, you got half of it. You got the x value. How do you get the y value? Plug it into the function. Yeah, that's good. That's what that says, and it's kind of logically what you would do. If you have the x value and you want the y value, you should plug it in the function. But that's what that says. Once you find this, it says please plug it into the function to get the y value. So that takes a little work. I mean, I got to plug a 2 in there. To get the y value, I'm going to plug a 2 in there. That's 2 squared. That's 4 times 2 minus 5. I mean, it's a little work. It's a step up from chapter 1, from chapter 2. But you're capable. You're smart people. That's a 4 minus an 8 minus a 5. You got to kind of do things in order, left to right. 4 minus 8 is negative 4 minus 5. I think I get negative 9. Your calculator could help you do that, but I think that's what I got. Cool. There we go. We found the vertex. Hey, I want to show you how much you just learned here. I want to sketch a graph of this, by the way. Besides all this great information, I also want to sketch a graph. So I'm going to come over here. So we just found the vertex. I think I can put it on the graph. 2, negative 9. Yeah. 2, negative 9. So there's the vertex. Now it's a parabola. Does it open up or open down? Which kind is this one? It opens up. How do you know that? Because of this positive 1. Yeah, this leading coefficient being positive. We call that the leading coefficient, or A. Because it's positive, it opens up. So in a way, that's the vertex. It opens up. I mean, I could draw it real quick. There it is, you know. Hold on. To be a little more accurate, let's... maybe we want the x-intercepts, except those are difficult. We'll get to those. Let's skip that a second. Everybody knows how easy the y-intercept is. How do you always find a y-intercept? Let x be 0. You've learned that already, and it applies again. It always applies. If you want the y-intercept, you let x be 0. And it's usually easy. We're going to study other functions this semester. The y-intercept's usually easy. The x-intercepts are usually tougher. That's kind of how it goes. But this is easy, man. Plug in a 0. What do you get when you plug in a 0? You get negative 5, I think, don't you? When you plug in a 0 and do a little math, you get negative 5. You know what you could do? You could memorize that this. Number. Let's plug in a 0 up here. If you plug in this, you'll always get C. That number C is always your y-intercept. Again, you can memorize it like, oh, he told me that C was the y-intercept. Or you can do it by plugging in a 0 for x. You know, it confirms what you've memorized.
So it's always going to be 0 and C?
Well, a y-intercept always has x equals 0, and it's always going to be that C. Now sometimes as we go through this chapter, sometimes these things are in different forms, and if it's in a different form, then maybe that's not the answer. But in this form, plugging in a 0 always gives you C, so that's always the y-intercept. Yeah. Hey, so I'm going to put that on my graph. That's about right there. You know, now I can kind of draw a decent graph. It is a parabola that opens up, and I have the vertex, and now I have this one point. So that just kind of helps me get the width of it in a way. You know, the other side should be symmetric. So I'm going to just try to, I mean, that's not too bad. And you can answer this last question, especially now that you got the picture. You can definitely answer this last question. What is the range? The range is the y values. And thank you. From -9 on up. Yep. From -9 up. You can say that a couple ways. Y is greater than or equal to -9. That's a good way to say it. But you guys have been working on your interval notation, which makes you say -9 to infinity. Including the -9, it reaches the -9. Cool. So you can do a lot of great work. You can get a lot of partial credit. But we've avoided the difficult part. The difficult part is those x-intercepts. I'll get to that. So what did I do? I found the vertex, the y-intercept, and I got a graph. I just needed the vertex and the y-intercept, and that really gave me the graph. The x-intercepts, knowing those x-intercepts might help me even get a more accurate graph. Maybe I could have waited until I got the x-intercepts before I sketched this graph, but I was happy to sketch this graph. The vertex. I mean, what did I know? I know 3 things. I knew the vertex, I knew which way it opened, and then I wanted to plot one more point, so I plotted the y-intercept. That's the 3 things I did. I found the vertex, which way does it open, up or down, and just plot one more point, plot the y-intercept, and you got a good graph. And you've answered a bunch of these questions. Because once you have the graph, you can do the range. Well, let's get to these x-intercepts, since we're going to quit avoiding them now. Okay? How do you find x-intercepts? How do you always find x-intercepts? You plug in a 0 for y, she said. So I'm plugging in a 0 for y, right here. The 0 for y, and then I got to solve a quadratic equation. Now I got to solve a quadratic equation. And we haven't done much of that at all, or hardly at all, or at all. But now we will. And it's really not something I'm going to teach you. What I'm really doing, though, is I'm reminding you how to solve quadratic equations. You kind of know, I think, but I'm reminding you. The best way to solve a quadratic equation, one way to solve a quadratic equation is factor it. So that means I got to remind you about factoring. But these typical trinomials like this is a typical trinomial. It factors into 2 binomials. And this is factoring. The first 2 have to multiply to be x squared, so it's probably an x and an x. The last 2 have to multiply to be 5, so probably what multiplies to be 5? 5 and 1. You got to get the signs right. It's got to be a -5, so somebody's going to be negative and somebody's going to be positive.
Which one will go first?
It might not, because I have both of these are x's, it might not matter. I'm going to try a -5 and a +1. Is that what y'all were thinking? Because what you're trying to get also then is you're trying to get your middle term. See, we've got our first term, x times x is x squared. And we've got our last term, because that's a -5. To get your middle term, you're checking this. Let me show you. You're checking your inners and your outers. If you multiply those inners, that's an x. If you multiply those outers, that's a -5x. What does that add up to?
-4x.
Well, I'll be damned. Then we got it factored. We're perfect. We just checked it. We just sort of multiplied it back out to check our factoring. If you foiled this back out, it should be this. We're unfoiling it. We're factoring it.
So the x-intercept is -5.
Not yet. Hang on. Then we run into, so now that it's factored, the end of this is easy, but you got to, there's this concept. You ready? It's a concept. You ready? When you multiply two numbers and the answer is 0, what's got to be true when you multiply two things and the answer is 0? One of them's got to be 0. Right. And so what you do then is you set each factor equal to 0. Set each factor equal to 0. So you set x plus 1 equal to 0. Now when you proceed to solve, of course you'll move the 1 over, and what's the answer? -1. I'd like your attention. If you are doing something else, you're losing your mind. You can't do other things. You got to give me your attention, please.
You do that to 5 too?
Yes, you set the other factor equal to 0. You set the other factor equal to 0. You move the 5 over, and x equals 5.
So you just change the sign, basically.
Well, yeah, I'm not going to agree with you. I'm going to say do what I do. There's more to it than just changing the sign. You have to solve for x. On this example, you are right. On different examples, other examples, you might be wrong with that thought. So there's more to it than just changing the sign. But that is an important thing, though. Listen, the factor x minus 5 produces the answer +5. I mean, there is something to that is important, and it's important for chapter 4. It's important as we go. Whatever the factor has, there's a minus sign in the factor, the answer is going to be positive. There's a plus sign in the factor, the answer is going to be negative. And the reason is because you set it equal to 0 and move it over, Right, there's logical reason to it. But we just found 2 x-intercepts. I think I'm going to go put them over here in my little answer here. There are 2 of them. Listen, you don't write them together. They don't go together. X is -1, and what was y? Do you remember what was y?
0.
Thank you, 0. Thank you. That's what made it an x-intercept. The other one was x was 5, and what was y?
0.
Right. It's 2 distinct points. I mean, some students put them together. This really makes me angry. Don't ever do this. Don't even look up here. You with me? They don't go together.
Because one of them's a y, man.
Right. These are 2 different x's. Don't put them like this looks like an x and a y. Right. That's awesome, you guys. Hey, did you know there was going to be 2 x-intercepts? I guess you could have predicted it. You got a good picture here. This was a 2 right here in the middle. Wasn't this a 2? At this 2, because that 2 brought me down here to the vertex. That 2 is kind of a line of symmetry. They actually call that x equals to the axis. They call it the axis, or they call it the axis of symmetry. But those x-intercepts live symmetrically away from that, I think. What did we just find for our x-intercepts? We found 5 and -1. How far away is that over there? That's 3 units away. How far is this away? Yeah, that's how it should be.
Symmetric.
Yeah, mean, it's a symmetric parabola. It's symmetric. And so those x-intercepts are symmetric to wherever that vertex was, or the axis of symmetry. This isn't a lot of new language. That's what happens with a new chapter. New language, new terminology. Some old ideas, like finding a y-intercept, that was an old idea. Finding an x-intercept was an old idea, but what was new was I had to solve a quadratic equation. I had to solve a quadratic equation. And that involved factoring. There's several ways to solve quadratic equations. There's several ways to solve quadratic equations. One way is factoring, like we just did. We solved it by factoring. Any questions?
Are we gonna have all of them be just one of the coefficient for the x squared? Or
No.
Yeah, okay.
No. Any
That's-
other questions?
That would be whenever you couldn't just change the sign on the x-intercept, right? If you had like 2x plus 1 and then 2x.
Oh, right. So these factors can get, so we'll do, these factors can be more complicated. Yeah, he's right. Just, I'll tell you what, this is just to answer his question. What if this was your factor? 2x minus 3 and 5x plus 8. And you would set these each equal to 0 and you would get yourself a couple answers. Do you know what they would be? You would set 2x minus 3 equal to 0, and what would be your answer?
3 over 2.
Good, you move the 3 over and you divide by 2, so it's 3 over 2. Notice again, the factor that had the negative sign ended up with a positive answer. But the answer is not 3, the answer is 3 over 2, right? You set this equal to 0 and solve. And once you're good at it, you can do it in your head. You set this equal to 0 and solve.
8 over 5.
Negative 8/5.
Okay.
You with me? I mean, I could write it down. You can write it down. You set this equal to 0. You move the 8 over. You divide by. I mean, this is you want. Yeah, once you're good at it, you can do some of these moves in your head, right? Let's. I'm going to do another example. I'm getting rid of this one. Here's another example. I'm sorry, but I want the same things. I want the vertex, the x, I want the same. This is what I want. This is how my test questions, my quiz questions kind of look. I like all this information. And I want a graph. So this is kind of easy. Let's do the easy stuff. What's the easy stuff? The vertex. Okay, the vertex. X is negative b over 2a. This one's got a little twist in it. What's my b?
0.
My b is 0. Yeah. You see that? What's your a?
-2.
Your a is negative 2. Your c is 18. But see, there's no b term. That x term is missing, which means b is 0. That's okay. It makes it easier, is what it does. When b is 0,
Isn't that addition squared?
so the x value is, what are we saying? Negative b. b is 0. All over 2a. I mean, that doesn't even matter. 0 over any number is 0. So the vertex x value is 0. When you plug that into the function, you get the y value. Is that right? To get the y value of the vertex, this is your x equals negative b over 2a, and that's your fancy little formula to get the x value of the vertex. Once you got that, you just plug it back in to get the y value. What's that? 18. That zero's throwing you all off. Everybody's a little confused, I can tell.
Because if B, wouldn't B be 18?
No, I'm sorry. See, B is the number in front of X. C is the number without any X. So C is the 18, no doubt about it. A is the -2, and this.
Oh, okay.
There's
I
Okay.
see what you mean. I got you.
Okay, good,
Okay.
good. So B just doesn't exist in this problem, or it's 0 in this problem. And that tends to, when it's 0, it's missing. It tends to be a little weird for students, but it really makes the problem easier. When it's a 0, this formula works out pretty easy. You know what's funny? Let's skip down to the y-intercept. How do you guys find a y-intercept? You let x be 0, and what do you get? You get 18. This is kind of a funny situation. This didn't happen last time, but what you have on this problem is the vertex is the y-intercept. I guess it's up here at 0, 18 up here. And it just happens to be that the vertex is the y-intercept because this parabola sort of just lives on the y-axis, I guess. Does he open up or does he open down?
Yeah.
He opens down, and you kind of know that he's a little skinny, don't you? If you remember that, he's just a little skinnier. But you see that problem? The vertex lives on the y-axis. The vertex is the y-intercept. That happens when b is 0. It happens when b is 0. And listen, you already kind of know that. Let me show you why you already know that. Thinking about shifts, back last week, thinking about shifts, you would probably say this thing is shifted up 18. It's shifted up 18. It's upside down. It's a little bit skinny, but it's not shifted left or right at all. Can you can tell that? Can you, based on there's no left or right shift, so it's only a shift up 18, which makes it live on the y-axis, so to speak. Okay, cool. That was supposed to be easy. Hey, you want to tell me the range? Okay. I think I heard you. Negative infinity is the lowest place. Up to 18 is the highest place. That's a good way to say it. Low to high. Left to right, low to high.
So will the range will always have the bracket on the end, a 1-0?
Yeah, the range, I mean, does it reach that 18? Yes, it does.
Okay.
It reaches 18.
So there will always be a bracket in the range.
That means the bracket means it reaches that point, yes, and it does. And on a vertex, it reaches that point, yeah. All right. Easy stuff. Vertex, I mean, that's new. That vertex formula is brand new. Y-intercept wasn't a new idea, but anyway, and the range is not a new idea. But these x-intercepts are kind of a new idea with regards to, we got to solve a quadratic equation. If I want the x-intercepts, I let y equal 0, and I try to solve this equation. I mean, I'm solving a quadratic equation. And last time, I used factoring. This time, I think I want to try a different method. I don't know what, you could use factoring on this one actually. You could factor out a -2, and then you could proceed a little further. I don't know if you guys see all that, but I don't want to factor. I got a different idea. Do you know what it might be? What would you do? What would you do to solve for x, maybe? You might subtract the 18. The truth is, I think I'll move this guy over instead. I'm going to add the 2x squared to this side. To get x, I can do this. I couldn't do it last time. It was a different setup. I couldn't really solve for x without factoring. This time I can. I can get x by itself. You know what I should do next? I'm trying to get x by itself. What should I do next? Divide by 2. Good idea. Now I got x squared equals 9. What move should you do? Square root both sides. Awesome. And so that's sort of my second method. My second method, and it works good when there's no b, when b is 0. Doesn't really work when there's a b. Actually, it doesn't work when there's a b. But when b is missing, you can do this thing called take the square root of both sides. I'm going to say it like that. Take the square root of both sides. So my next step is take the square root of both sides. I take the square root of this side and I take the square root of this side. What's the square root of x squared? X. What's the square root of 9? It is 3, but in this context, we also have to open our brain and think about all the possibilities that x could be, and it could also be negative 3. Well, what number squared would give you 9? It could be a 3 or a negative 3. So when you square root both sides, it's your job to remember to introduce what we call it the plus and minus symbol. So when I take the square root of 9, I put plus or minus 3. And I introduce that plus and minus symbol because I did this step called take the square root of both sides. It gives me my 2 answers, plus and minus 3. I mean, look at the graph. Did you expect to be 2 answers? I mean, look. It looks like there's going to be 2 x-intercepts, and there they are, negative 3 and 3. I like that. I like solving, but this is a special case. This square rooting both sides, getting x by itself. This was not factoring, and it only worked because b was 0.
Are there extra questions like this, the plus or minus negative 3, or plus or minus 3, on My Math Lab?
Yeah, there should be all sorts of this on My Math Lab. Yep. Right. And you should do your My Math Lab homework. And you know what? I think it's a little bit heavy here. I think I think this is important stuff that I assigned more problems. There might be 18 or 20 problems in this section. I don't know. Any other questions about what I did? Did I lose you anywhere? Oh, when I write the answer, what should I write over here? I should fill in my answer. What should one of them is negative 3, 0. What's the other one? 3, 0. You with me? I mean, that's how you write it. Somebody wanted to be smart and write a little less. Is it okay if they wrote plus and minus 3, comma 0? I think that's clear. I think I know what you mean. If you know what you mean, I think I know what you mean. There's 2 x-intercepts. You just wrote them together. Well, I got more good examples. You ready? Let's do another one. We'll leave this one. We'll do another one. Here's another one. F of x, this is probably the best one, okay? So 3x squared minus 4x minus 2. 3x squared minus 4x minus 2. All right, you guys. Same old thing, same old thing. I want to find all these things, the vertex, the x-intercepts, the y-intercepts, the range. Same old thing. What do you want to start with? I mean, people like to work in order, I suppose. People like to work in order, I suppose. But sometimes I like to just pick the easiest thing up here. What's the easiest thing up here? The y-intercept is the easiest thing up here, isn't it? I'll just do it first real quick. I plug in a 0 for x, and what do I get when I plug in a 0 for x? Negative 2. Okay, so I just found my y-intercept. Get some partial credit. But you're right, let's go for the vertex. In order to do the vertex, I need the x value. The x value is negative b over 2 times a. Okay. I guess that's a 4 over 6. which reduces to 2/3, which, if I wanted to make it a decimal, it ain't the prettiest decimal. It's 0.66666666 forever. Right? That's what 2/3 is. So I think I'll just leave it a fraction. X is 2/3. How do I get my y value? No, hang on. The y value of the vertex you get, once you have the x value of the vertex, how do you get the y value? You plug in 2/3. You plug in that x value to get the y value that goes with it. This is the y value of the vertex. This is the x value of the vertex, and you plug it in. So that's 3 times 2/3 squared, 4 times 2/3. I love fractions. Even if you don't love fractions, just say you do. It's called positive thinking. You change your brain. You just tell your brain you love fractions. You can trick yourself. Trick your brain. How do you square 2/3? Square 2/3. Square the 2 and square the 3. What is that? 4/9. Yeah, that works. Do you know how to multiply this fraction? It's a 4/1 times 2/3. You know how to multiply?
Crisscross.
No, straight across.
8/3.
8/3. That's how you multiply fractions. That's a -2. Hey, this is multiplied by 3, which is going to cancel if you don't mind. Is that okay with you?
Yeah.
So now I've got a 4/3 minus an 8/3 minus a 2. You know, maybe I should change that 2 into having a common denominator. How do you make a 2? I need a common denominator of 3. How do I make a 2 have a common denominator of 3? Multiply it by 3, so I have to multiply it. So 6/3? Is 6/3 a 2? 6/3 is a 2. All right, cool. I got it finally. A little bit of fraction work. Never hurt anybody. What do I got? 4 minus 8 is -4/3. Minus 6, I think, is -10/3, I think.
Wait, where did you get the 6 from?
Well, I had to change 2/1 to get a common denominator of 3. So 2/1 turned into 6/3. 2/1 turned into 6/3. You know it. Yeah. You got it. Wow, that was fun. Hey, if you're doing this on a calculator, you could have got this. You would have probably been in decimal form, unless you can get your calculator to work in fraction form. Maybe some of you got some cool calculators. But if you are in decimal, what is this? This is -3 1/3, right? -3.1. I mean, 3.33333. Yeah, 3 1/3. I think.
Yeah.
Okay. Good job. Hey, as you can tell, I don't know. This is a step up, right? We're in chapter 3. Maybe you can already tell everything's just a step up of difficulty. And it's not that it's difficult, but it's just the work is a little more. There's more to it. There's more to it than lines and slopes. Okay, that was kind of easy. There's a little more to it. More places to make mistakes. If you're slow and careful, you don't have to make a mistake. You can get it right. What's my vertex? 2/3, -10/3. That's what I'm going to write. I'm going to go draw a picture of this thing. That vertex is 2/3, -10/3. We already said 2/3 is, right here, I guess. And -10/3 is 1, 2, 3 1/3. If you don't mind, that's -10/3 right there. That's 2/3. And that's my vertex. I kind of this is where my little line of symmetry is here. I don't have to draw that line of symmetry, but that's it. What's the y-intercept? -2. Huh. I guess I was going to ask you, does this open up or open down? But I got the vertex and the y-intercept. I guess I should know it.
Yeah.
It opens up. Does it open? Yeah, it opens up. Right, opens up. If it's positive, if the leading term is positive, it opens up. So we got the vertex. We got the y-intercept. I'm ready to graph it. It's probably a little narrower than that. Remember, it is a 3 there. It might be a little skinnier or narrower. But I'm okay. What would help my accuracy, of course, is if I plotted those x-intercepts, which I'm going to find anyway. I'm going to make you find the x-intercepts anyway. But if I plotted them, that would help. How are you guys doing? You guys all right? Any questions? You want to fill in this range? What's this range? I'm going to just write y is greater than or equal to negative 10/3. Yeah, that's the range. You can see that maybe. All right, what else? Let's do it. All right, we need the x-intercepts. I'm going to erase this if you don't mind. I need my space here. The x value of the vertex is pretty darn easy. Plugging it in to get the y value can take some work, as you can see. But you should just take your time and don't make mistakes. You should be fine. But that one involved a bunch of fractions. All right, so how do I find the x-intercepts? Set this equal to 0, and now I'm solving a quadratic equation. We said that maybe we could factor it. Guess what? Not all quadratic equations factor. They don't always factor. Some of them just don't factor. And this is not a good one for taking the square root of both sides because of that x term. See, when you have that x term, you can't just square root it. That's so. When he's missing, anyway. So I don't think it factors. I could try. Let me try something here. It has to be a 3x and an x. Do you agree? Oh shoot, maybe it does factor. 2 and 1.
Yeah, that's all I got.
No, why don't you know?
Why not? 3 plus 3 times 1 is 3. And then minus 2.
It might factor here. Hang on. So it's got to be 2 and 1. One of them's got to be negative. One of them's got to be positive. See, if I put the 2 here, what is that? 6x. If I put the 1 here, that's a 1x. 6x and 1x. Man, that won't work, will it? All right, hang on. What if I put the 2 here and the 1 here? Well, that's a 2x and a 3x. Can you get a 2x and a 3x to somehow be a 4x? No, I guess not. Yeah, never mind. It doesn't factor. For just a second, I thought maybe it did. You can talk yourself into it, but it doesn't. So it doesn't factor. Hey, do you guys like factoring? Do you? Okay. I mean, I don't know. I think I've noticed over the years, algebra students don't particularly like factoring. But we need it as a skill to help me solve quadratic equations, which I need to help me find the x-intercepts of these things. But when it doesn't work, we got something that always works. It's called the quadratic formula. So the third option always works. It's called the quadratic formula. It always will solve quadratic equations. And you need to know this, and you need to memorize it. You definitely need to know how to use it. And I'll just tell you what it is. The answer is this magic formula. The answer for x is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a.
Yay.
Yeah, that's a lot. That's why it's college algebra. It ain't third grade algebra anymore. It's college algebra. Good job. Yeah, we got to memorize this and learn how to use it and practice using it. I'm going to help you practice using it right now. But we need the quadratic formula in this chapter. One way you can memorize, memorize it is you can sing it. You would sing it? You want to sing it for us?
Come on now.
You heard about how it goes? It goes to,
Little kids.
yeah, there's that weird song called Frere Jacques. Have you ever? Frere Jacques, Frere Jacques. It's a French song. Yes, Dormez. Anyway, so you sing it to that tune, and you kind of repeat, like Frere Jacques repeats itself. So you go like this. Negative b, plus or minus the square root, plus or minus the square root of b squared minus 4ac, of b squared minus 4ac, all over 2a, all over 2a.
It helps.
It helps, that's right. You can't sing on a test, you got to keep that quiet in your head. Maybe singing it to yourself will help you memorize it. Maybe not. Maybe just memorize it. You know what A, B, and C are, right? That's not a mystery, is it? In my problem, what's A? In my problem, what's A?
3.
And B?
4.
-4. And C? -2. So I'm going to do it. You ready? Here we go. I'm going to do the quadratic formula to solve this. I do the magic formula. The answer X is -b. Since B's already negative, I'm going to put a 4 there. Is that okay? That's -4. Plus or minus the square root, and now that b is squared. I think I'll write that for you. -4 squared. But what's that going to be? 16. It's going to be, I could write 16. I could do that part in my head, but it's b squared. Minus 4 times a, what's a? 3, and c is -2, all over 2 times a, which is 2 times 3. What happens when something doesn't factor and you have to resort to the quadratic formula, your answers are probably kind of funny looking, like, well, it probably has a square root in it, like square roots of 2s, or square root of 3, or square root of 11, or square root of 13. I mean, those are called irrational numbers. They're good numbers. But they're irrational. They're not like 2/3 and 10/3. Anyway, we'll see what we get. This is 4 plus or minus. Listen, your job and most of your mistakes come from cleaning up right in here. You know, this is a 16. What I like to do is, the formula says you're subtracting, but sometimes you're subtracting a negative number, which makes you add, and that's what I'm doing here. If I multiply those 3 numbers, it's a -24, but I'm subtracting, and I end up adding 24. Are you guys okay?
Yes.
One way I like to do it is just count up the negative signs. I see 1, 2 negative signs, I know it's going to be positive 24. And then I multiply the numbers. All over 6. It is all over 6. Some people just put part of it over 6. The whole thing's over 6. What is 16 plus 24? Square root of 40. All over 6. Look, those are the answers, you guys.
So you don't.
Well, I'm pretty happy you got here. But this can be simplified a little further, because the square root of 40 can be simplified. Do you recall simplifying square roots?
Yes.
I know it's not the funnest thing you ever did, but like if you have the square root of 12, do you know how to simplify that?
6 over 4.
You pretend it's you pretend it's a 4 times 3. Can you do the square root of 4?
Yes.
It comes out and it's a 2 on the outside, and the square root of 3 is stuck on the inside. That's equivalent to the square root of 12. It's a simplified version of the square root of 12. What am I going to do with my square root of 40? What am I going to do?
10.
Good. I'm thinking of it as a 4 times 10. I pull out the 2. I'm left with the square root of 10. When you pull out that 2, it's multiplied right in front.
Yeah.
Again, when you're in college algebra, these are I don't feel like I'm teaching you these skills. I feel like you're supposed to know these skills. But I do take 10 minutes and remind you of them, don't I? So I'm reminding you what you need to know to finish simplifying this problem. To tell you the truth, I'm pretty happy if you make it here. But I want to show you it's not simplified. And if you're doing your My Math Lab homework, or if I really want you to simplify it, then this might cost you a point or two. Let's finish this then. So watch what it is. It's 4 plus or minus. Now what did we just change that square root of 40 into? 2 times the square root of 10. Thank you. All over 6. You can cancel a 2. I like to say you can cancel a 2 only if you can cancel it in all 3 places. And you can. You can cancel that 2. You can cancel a 2 out of there, which would leave a 2. And you can cancel a 2 out of there, which would leave you a 3. You can cancel a 2 if you do it in all 3 places. So I'm canceling a 2, it leaves a 1. I'm canceling that 2, leaves a 2. I'm canceling that, leaves me a 3. So now what's my answer? 2 plus or minus square root of 10 all over 3.
So the 2 is canceled.
I canceled the 2 there, I canceled the 2 there, I canceled the 2 there. You could say you factored out a 2 and canceled it. That's one way to think. Or you cancel it in all 3 places. That's the proper way to cancel, though. Don't do improper canceling. You can only cancel if it's in all 3 places. Let me just show you something. I mean, just a little side step here for a second. If you had 5 plus or minus the square root of 17 all over 10, would you do any canceling?
No.
I wouldn't. I wouldn't. I'd leave it just like that. Because if you can't cancel it in all 3 places, then please don't cancel it. This is just wrong. Because the 10 is divided into both those things. And when you cancel it here, you're just assuming it's divided into him, I guess.
Which would be 2 separate division signs.
Yeah, you could do that, though. You could do that. Hey, you guys, we found our x-intercepts. What are they? You can't even say them, can you? Y'all can't even say them. Can you say them?
2 plus or minus square root of 10 over 3.
Thank you. Yeah, y'all can say them. Good. That's what they are. 2 plus or minus the square root of 10, all divided by 3. Those are 2 numbers right there. One of them is 2 plus the square root of 10 divided by 3. The other one is 2 minus the square root of 10 divided by 3. It's okay to write them all together, but I want you to make sure you understand that those are 2 answers. And for fun, let's decimalize those and see what they are. I wonder if you can do that on a calculator. Can you do the square root of 10 on your calculator? It's roughly a 3, right? Square root of 10 is roughly a 3. Add it to 2 and then divide the whole thing by 3. I'm looking for a decimal answer there.
Wait, what? Divided by
10 divided by 3.
Well, it's the square root of 10 plus 2 divided by 3. However you want to do it.
3.2659.
Parentheses are kind of important, maybe. See, you might have just, if you type this into your calculator, I want to show you something. If you just type it straight into your calculator like this, there's something wrong. You know what's wrong? Your calculator is only going to divide him by 3 and not the 2. If you use parentheses, now it'll divide the whole thing by 3.
So it's 3.
Or if you do it in little baby steps, like do your numerator, hit enter, and then divide by 3. Okay, I think I like that better. 1.72. And by the way, it goes forever. It's some irrational number. Irrational numbers, their decimal goes forever. It never repeats a pattern. It's 1.72, blah, 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 blah. What's this one? 2 minus the square root of 10 divided by 3. Can you do that one? Hey, do you know what these little squiggly equal signs are that I'm doing? Approximate. since I'm decimalizing it there, and I'm rounding off this decimal, I'm calling these approximate answers here. I'm using little approximate symbols here. Approximate. What's this one, please?
-0.387.
I think I like that. 3, we'll call that 3.9 maybe, -0.39. Two minus the square root of 10. You gotta pick up your calculator and try it. 2 minus the square root of 10, all over 3. I would put parentheses on it if I was typing it all in.
Sir, I don't know why my calculator's doing this.
Yeah, mine doesn't go like
Yeah,
this.
mine
It
doesn't
just
do
goes
that.
to a fraction.
Oh, well, so go to mode, and you might be in math print mode. Is that true? Find
You
your.
just have to push the arrows, these little arrows down here, push that, and then it will put it into a decimal.
Okay, so I'm telling them to change their mode, but you found another way.
Yeah.
You're saying,
If you have the fraction, and then you just push that button above enter, it will put it into a decimal.
she said, push the button above enter.
Right here.
Did that work?
Two little squiggly lines. Negative.
And it just makes it a decimal.
-0.39.
Yeah, yeah,
There we go.
it worked, huh? So I think your mode also. Okay, so I was going to say in mode you got math print mode or you got
Classic.
classic. Okay, maybe that helps too. Maybe that makes it decimalized. So you can toggle back and forth between modes. Anyway, let me just look on my graph. Remember, this is my graph. 1.72 was one of them. See this guy? 1.72. The other one was -0.39. See this right here? -0.39. Looks kind of accurate. Remember I said it probably should have been a little skinnier? I probably should have made it a little skinnier to be more accurate. That's pretty good. And we got them. And if I want to list them over here, I really don't want to list those approximate answers. I want to list the answer, which is 2 plus or minus the square root of 10 all over 3, comma 0. I mean, this is me. I'm listing both of them together at once. Is that okay with you? Yeah.
That's first 1.72.
Yeah.
How do you come up with that?
Well, 2 plus the square root of 10, all divided by 3. That's how I came up with it. The square root of 10. You can do it in real small steps. Do the square root of 10 on your calculator. Did you do the square root of 10? Well, then you got to find your square root button, right? Figure out how to use it. But after you get the square root of 10, then you can add 2. You can hit equals. You can do it in little baby steps. I like baby steps. But you can type the whole thing in at once also. I mean, it just depends on what you're comfortable with and what you can do. But you can do the square root of 10, then you can add 2. After you're done with that, you hit equals, and then you divide the whole thing by 3.
On the decimal, do you only just go to the second spot?
Yeah, maybe some directions tell you how to round, but it seems like hundredths, tenths, or hundredths is a good place to round these things, yeah. Now, what were you going to add?
On the test, do you prefer the x-intercept the way you did it, or do you prefer the approximate decimals?
Right. Well, there may be a question that kind of makes you do both. So I'm trying to get you to do the quadratic formula kind of exactly without your calculator. Then I'd like to know if you can use your calculator, because as we're practicing here, it looks like we might need calculator practice to get us. So I want to see if you can do both in a way. So I'd like to see this, and can you use your calculator and give me these answers as well. As far as putting it in this list, I'm not sure if I care. Maybe I want these exact answers. But if I see your work, if I can see everything, I don't care what goes here. If I'm looking at your work, I'd like to see your work. Listen, you guys, so I walked in and started talking about quadratic functions and the vertex and the x-intercepts and all that good stuff. Listen, here's where I am in your book. I think I opened with 3-3. And then when I started finding the x-intercepts, I was solving quadratic equations. That's solving quadratic equations. And then that's kind of 3-2. Well, so I didn't do 3-1, and you don't need 3-1 until later. So trust me. Some students hate that though. God dang it, you ain't in order. But you know, I present this material the way I think it should be presented. 3-1 talks all about imaginary numbers. I didn't need to start with that. I might need those later, and we'll get back to that. But if you go try to do that homework, you might be confused. So skip 3-1 for a while. Get into 3-3 and 3-2, perhaps. So we'll quit. Thank you for your attention. I'm going to hit off on this video. I got a lot of stuff to give you back.